In this video, we're going to talk about Learning Target 11B, and our learning target is I can use the counting principle to find the number of ways two or more events can occur. So here's an example of two events. You're matching up shirts or tops with bottoms, and how many different combinations are possible here. If you have two different shirts and four different bottoms, how many are possible? So the white shirt could be matched with these jeans, or it could be matched with these jeans, or it could be matched with these shorts, or it could be matched with these shorts. And then you would look at the black shirt and see the possibilities. So you're looking at the number of combinations of outfits that you could create. So we're going to talk about the vocabulary term tree diagram. That is one of the ways that you can find out the number of possible outcomes. The first way is making an organized list. So let's start with that. So here you are choosing an outfit, and you can choose a t-shirt, a button-down shirt, or a sweater for a top. And you can choose jeans or khakis for pants. So these are the three different tops you may choose, and these are the two different bottoms you may choose. And you're asked how many different combinations of outfits could you create. So to make an organized list, we would use letters like T for t-shirt, J for jeans, K for khakis. So maybe the TJ and TK are two possibilities. BJ and BK are another two possibilities, and SJ and SK are two other possibilities. So here's my organized list. In this case, we organized it by jeans and then by khakis. So if you wore jeans, you could choose to wear a t-shirt, the button-down, or the sweater. If you chose khakis, you had a choice between the t-shirt, the button-down, or the sweater. So there are 6 possibilities, and these were organized by the bottoms. 6 possible outfits are possible. In this example, we're going to make a tree diagram, which will help us make the organized list. So you have a choice of a t-shirt, a button-down shirt, a sweater, or a polo shirt. And for pants, you have a choice of jeans, khakis, or dress pants. So you're asked how many possible outcomes are there. So you can see that this kind of looks like a tree with branches. First, we start with the shirts, and then we match each shirt with each pair of pants. Each shirt with each pair of pants. The sweater with each pair of pants, and the polo shirt with each pair of pants. So when we make our organized list, we have TJ, TK, TD. Then we have the button-down jeans, button-down khakis, button-down dress pants, and so forth. So you can see we have 12 potential outfits from these tops and bottoms. So to make this go easier, there's a counting principle. So you don't have to make an organized list or create a tree diagram if you have many possibilities. So for example, it says if one event can occur in M ways, that would be possibly the number of shirts or tops. And for each of these, a second event can occur in N ways, that would be possibly the number of pairs of bottoms you would have. Then the number of ways that the two events can occur together is M times N. So we would multiply the number of tops by the number of bottoms to find out the total number of possibilities. So here we have 4 tops times 3 bottoms, and we get 12 different outfits that are possible. So let's use our counting principle when we're talking about creating a skateboard. To create a skateboard, you need to choose a deck and a type of wheel assembly. So there are 5 different kinds of decks, and 3 different kinds of wheel assemblies. So if we took our 5 decks and multiplied it by our 3 wheel assemblies, we'll find out how many different combinations are possible. In this case, there's 15 different combinations. For example, this deck could be matched with these wheels, this deck could be matched with these wheels, or this deck could be matched with these wheels. So for each deck, there are 3 possibilities. 3, 6, 9, 12, 15 total possible combinations. You can build 15 different skateboards. Here you're choosing a password that starts with 3 letters and then has 2 digits. How many different passwords are possible? Now, making an organized list of this or creating a tree diagram would be very labor intensive. So let's look. For our letters, there are 26 different letters. So the first digit would have 26 possibilities. The second would have 26 possibilities because we know the first 3 are letters, and the next would have 26 possibilities. Then we have 2 digits. So there are 10 digits. 1 through 9 are each digits, but we also can't forget 0. So that makes there's 10 total digits. So we're going to multiply by 10 digits, and then multiply again by another 10 digits because there's 2 digits at the end, 3 letters and 2 digits. If we multiply these out, we get 1,757,600 combinations. So you can see there's a great advantage of using the counting principle instead of simply making an organized list or creating a tree diagram. Okay, let's see how this works. Number cubes are dice. So you and 3 friends each roll a number cube. What is the probability that you each roll the same number? So it doesn't matter if you all roll a 1, or if you all roll a 2, or if you all roll a 3. You're just looking at the possibilities or the probabilities of all rolling the same number if there are 4 number cubes. So the first step would be to list the favorable outcomes. Here they are. Any of these would be great. The goal would be for all of you to roll the same digit. So all of these are possibilities that would win. So there are 6 possible wins for these dice. If we use the counting principle to find the possible outcomes, we have 6 possibilities for the first dice times another 6 possibilities for the second person rolling the dice times another 6 possibilities for the third person rolling the dice times another 6 possibilities for the fourth person rolling the dice. That equals 1,296 possible outcomes. So let's look at the probability. That would be the number of favorable outcomes over the possible outcomes. We know there are 6 favorable outcomes. If those happen, then it's a win. And we know that there are 1,296 possible outcomes. Now, I would need to reduce this, so we would have 1 out of 216 possible. So the probability that you each roll the same number is 1 opportunity or 1 chance out of 216. Okay, so let's see how you can do on your own. Your soccer team's uniform choices include yellow and green shirts, white, black, and green shorts, and 4 colors of socks. How many different uniforms are possible? So you need to multiply the possibilities of shirts by the possibilities of shorts by the possibilities of socks to find out the number of different combinations. Go ahead and try that. And the next one, you are choosing a password that starts with 3 letters and then has 2 digits. Oh, well, this sounds familiar. However, the passwords may not start with an A. So A cannot be the first letter. And they don't use the letter Q. So none of the 3 letters could be a Q. How many different passwords are possible? And then explain where you got the numbers that you used to multiply. Before you finish, tell me something that you learned or were reminded of and a question that you have.